morning. Welcome, everyone, and thank you for joining us for today's session in our Research in Focus webinar series. I'm Cherie Spurta, Executive Director of City Building Ryerson, which is a new university-wide initiative to mobilize and build collaborations for research in city building and urban innovation across Ryerson campus. I would like to begin with a land acknowledgement. Toronto is in the Dish with One Spoon territory, which is a treaty between the Anishinaabeg, Mississaugas, the Haudenosaunee that bound them to share the territory and protect the land. Subsequent Indigenous nations and peoples, Europeans, and all newcomers have been invited into this treaty in the spirit of peace, friendship, and respect. My co-moderator today is Roderick Zhang. Roderick is a graduate student from the Laboratory of Innovation in Transportation, and that's located in the Civil Engineering Department. He completed his undergraduate degree in physics at the University of Toronto, where he specialized in planetary climates. He is currently working on building a link-level air quality profile in downtown Toronto for emission control and public health purposes. So we'll have to circle back with him at another time to have a webinar to showcase his work. It's very interesting, but Roderick has a very keen interest in Dr. Oiamo's work, so we're really happy to have him with us today as my co-moderator. Welcome, Roderick. Okay, so just quickly, our run of show and housekeeping. Dr. Tor Oiamo will present his research, and then we will have a moderated Q&A, some questions from Roderick and me, and then some questions from the audience, and this should take about 30 minutes. At that point, people are free to leave. Our webinars are only half an hour, so it gives people time to fit it into their day. However, if you want to stick around, we have what we call an after party, where audience members who wish to stay can take a deeper dive into the technical aspects of the research and the discussion. Overall, our audience mics and cameras will be off during the first 30 minutes. And so we welcome you to submit questions using the Q&A window at any time, and feel free to use the upvote button to vote for the questions you'd like to see answered if you don't have one yourself. And this webinar, along with others in the series, will be recorded and posted on City Building Ryerson's website. And I believe once we get into the after party, we have the option for audience members to turn their microphones back on, and then you can be part of the conversation. So hopefully some of you stick around. All right, let's get started. I'd like to introduce our special guest. Dr. Tor Oiamo is an associate professor in the Department of Geography and Environmental Studies at Ryerson University. His current research focuses on environmental exposure assessment through the development of environmental models of noise and air quality, novel population exposure metrics, and simulation systems to assess health impacts of urban change. These efforts complement urban research activities that aim to further our understanding of environmental determinants of health, as well as acute and chronic disease risks in vulnerable groups. Through collaboration with organizations such as Health Canada and Toronto Public Health, and with past or current support from all Tri-Council funding agencies, these research activities are oriented towards environmental decision-making and policy. Dr. Oiamo also teaches on topics broadly related to geospatial methods, sustainable development, demography, and environmental health. In today's presentation, Dr. Oiamo will specifically share his studies into traffic noise levels across Toronto and their effects on local populations and links to chronic health outcomes. He will also explore the notable variations in noise exposures throughout the city and implications for vulnerable populations. So welcome, Dr. Tor Oiamo. We will now invite you to share your screen.
Okay, thank you very much for the introduction. I'm pleased to be here. Always excited to chat about noise. So just give me a second before this is shared. Okay, everyone can see that fine and hear me?
That's perfect.
All right, great. So again, thanks for the direction. Thanks for joining, everyone. I know it's a busy time of year for us at the university, at least, probably everyone. And as mentioned, I'll be getting to specifically road traffic noise, but this is a bit more general as well, just thinking about environmental noise in urban environments. So the reason many of you are here are probably in part due to this article or other articles like it that have been coming up recently. This was published in BBC and actually gave a really good overview of the state of research and environmental noise and where we are right now with our understanding of impacts on health and disease. There's been, I would say, a sort of steady and increasing attention to this topic in media over the last few years, which is great. The reason I'm here is in part my background, literally and figuratively, as you can see behind me. I like sound and noise, don't use those enough as it is, but I started my research in neurophysiology and biology, which are really important parts of this field, into being interested in and learning more and integrating cognitive and psychological aspects, which are important in noise. This field also integrates urban planning and urban development and how it will be mitigated, of course. Other aspects, such as thinking about how these things change over time, and the opportunity and need to use computer modeling, environmental monitoring, analyses to actually look at this, gives it a good starting point for me. I have a short attention span, so I can sort of move between a lot of different areas that are very different and important in this field. So just a few projects, just to note what I'm working on or have worked on recently with respect to noise, at least. So most of the work that I'll be ending up with today, at least, started with this environmental noise study in Toronto, which was a part of the noise bylaw review through Toronto Public Health. So this bylaw was updated in 2019 or 18, and we started in 2016 with doing a citywide assessment for that. I also worked with transportation services on the King Street Transit Priority Corridor, where we assessed noise and air pollution levels before and after implementation of that, which went to council for their consideration. I've been working with a Canada-wide consortium called the Canadian Urban Environmental Health Research Consortium on developing good noise estimates across the country that could be used in sort of large health cohort studies. I'm currently working with Health Canada to look in detail at noise and air quality emissions around one of the biggest train yards in Toronto. Sort of more tangential, but also projects that will include noise are climate and environmental change health vulnerability project with CIHR, and then as Therese mentioned, this development of a simulation system for assessing future impacts of urban transportation and land use development for planning and health impact assessment purposes. So this figure here is actually a map that we made to assess the traffic noise impacts in three dimensions following the reduction in traffic volumes along the King Street corridor. Of course, you can't see the details here, but just to kind of give you the scope of the technology and availability and possibilities that exist in noise monitoring and exposure assessment today. Just very quickly, just so we understand what some of the basic technical concepts, I guess. There's, it can be easy to confuse, even in the literature, noise versus sound. But noise, of course, is unwanted sound, or what we generally or all should perceive as unwanted sound, which is why we normally end up focusing on transportation sources, which are the most ubiquitous unwanted sound sources that we have. So we use the decibel level, which is really a simple measure of the amplitude of the sound wave, which is a physical property. We adjust that, we call it an A weighting curve, to adjust for our sensitivity to frequencies in different ranges as humans. We seem to think high frequency noise or sounds are louder than lower ones at the same power levels. And then in these health studies, for better or for worse, we use these average levels either over an 8 or 16-hour period during the day, or we focus on the nighttime, or we take a 24-hour average, and that's how we assign exposures to people. Just to kind of get a sense of what those levels actually mean. So in a city like Toronto, you'd be hard pressed to find any location anywhere in the city that has a sound pressure level lower than 40 decibels. I think the lowest I measured was 43. And then we can get up to as loud as 120 decibels when for example, a police car drives by with their sirens on. Because it's a logarithmic scale, this is not a linear increase in our perception. So actually a 10 decibel increase in the noise level, we perceive as a tripling in the loudness of that level. So from 40 to 100 decibels is a significant difference, or even from 40 to 50 is very perceptible. We tend to start talking about health effects above 50 decibels, and that's what most of the studies to date are showing. That's also the level at which regular conversation becomes sort of interrupted by background noise levels. So on this noise versus sound topics, so sound is hedonic. It can be both pleasant and unpleasant, and there's some arguments to be made for actually looking at it this way, but we do, in my field at least, really just focus on the negative aspects. We have not yet to date done anything significant in thinking about how, or assessing at least how pleasant sounds can actually improve health, really just looking at how noise has a negative effect on health. There's, of course, as there is with sound, some subjectivity and perception involved with noise as well. So these noise sensitivity and annoyance are common metrics or measurements that we think about. And I've shown in the study of Toronto, and it's been shown elsewhere, that these can actually be moderated or they're influenced by both individual and neighborhood characteristics, which of course makes them a little tricky to deal with when we're looking at large health studies. But the jury's still out on whether or not annoyance or perception actually matters for disease outcomes. So some studies show that it doesn't really matter how annoyed you are. You're still at risk for health outcomes, while others see a bit of a link, sort of a moderating effect of annoyance. So that's one topic that still needs to be determined. So the soundscape research field is one that I'm certainly interested in, but haven't had a chance to do much in yet. And this is one that's more holistic, sort of thinking about sound as an hedonic property, and are more concerned with topics like quality of life, thinking about acoustic qualities of green spaces and streetscapes, which are of course really important, but requires a bit of a different approach than the health studies that I've been involved with. So with respect to noise and health research, there's been a lot of advances over the last 20 years or so that's led to really an explosion in the number of studies, but also the quality of them. Part of that is due to much better exposure assessment capabilities, both predominantly through modeling, but also some better use of monitoring capabilities. There's improved access to patient or population cohorts, as well as clinical data. So we're actually able to link environmental conditions together with data on people. And that then includes things like residential history. So we can go back 15, 20 years and assign exposures to where people lived throughout a number of years. We can also link these to administrative data sets like income from Canada Revenue Agency. And then there's a number of maturing cohorts that started up in the 90s and 2000s that are now providing very good opportunities for assessment. One of them is the Ontario Population Health and Environment cohort, which was used in a couple of studies that I'll discuss here shortly. Lastly, but also very exciting, are improved quality and reduce costs of biological assays and panels. So we can actually now, with biological sort of certainty, go in and differentiate stress from noise exposure, perhaps from different sources. But importantly, sleep disturbance is one that we'll be able to quite soon, I think, pinpoint the biological mechanisms for. So we can now run these really detailed panels of endocrine, so hormone secretions, inflammation, vascular dysfunction. All these things can actually be assessed clinically now at a reasonable cost. So this is the general pathway that we know exists for exposure to noise and to these endpoints of concern that include cardiovascular disease. So I won't go through it in detail, but you can see right from the beginning, there's what we consider direct versus indirect effects. So these indirect effects then include disruption of sleep and performance, communication, can perhaps be influenced by cognitive and emotional reactions, leading through a number of biological, physiological responses, reactions in your system, and sort of a cascade of responses that over a long period of time can manifest as these cardiovascular disease outcomes. In Europe, part of the call and part of the reason for an increased focus on this, and also as a result of better capabilities in doing these studies, the WHO in particular for the region of Europe has done a lot of work in supporting and promoting our understanding of noise. So in 2011, they calculated a burden of disease outcome for a number of outcomes and found almost 1 million dailies were lost to sleep disturbance. So dailies are essentially a combination of both years lived with some type of disability, as well as years lost to premature mortality. So these are life disability adjusted life years. So I won't go through them all in detail, but you can see there's tens and hundreds of thousands of these for different types of incomes. And we've done some calculations in Toronto and other cities in the area, which have not yet been published, by using the exact same methodology, where you can again see that there's a pretty significant cost to this on society that again we're able to pinpoint better now than we were in the past. So on to a bit more specifically about the research that I've done or continue to take part in Toronto to assess these noise exposures. And this was in part done for the bylaw review with Toronto Public Health. We used a couple of different approaches. One of them was putting up in the map on the bottom left there, over 200 monitors in strategic locations around the city, that these were sites of concern for the city, as well as sites that would permit validation of more traditional modeling techniques. So these are what we call propagation models. And because noise is sound is a very predictable physical property, if we know how many cars are in a particular area at a time, and we know what the built environment looks like, we can actually predict with very high precision how that sound wave is defined and how it propagates throughout the environment. It's a really data hungry process, and for that reason can be tricky to do with big areas like Toronto. And part of the reason for using then this other approach based on monitoring was to make sure we had good sort of control and understanding of different sources and how they contribute to it. So it's a point I can't dwell on too much, but not all noise is the same noise. Different sources have different health effects actually. So it's really important to know where they come from. If we just put up a microphone and it's not actually recording noise, it's recording sound, and we don't necessarily know if that's good or bad for your health just based on those levels. Following these methods, then I was able to make very detailed noise exposure assessment maps that we can use then to assign to either neighborhoods or buildings or health cohorts, however we did it. So these have a 10-meter resolution. So on any 10-meter grid plot in the city of Toronto, we have an estimate then of traffic noise and total noise levels. And then I also use these to assess exposures on every single building facade in the city, which is what's really needed for the state of the art in health impact assessment. We're not quite there yet in the Canadian context of assessing noise, literally at the bedroom window of people's residences. There's some challenges and differences in European approaches and what we're doing here yet, but we do need to get to that point if you want to be part of the progress. So I found that depending on what time of the day you look at, around 60% of all noise variability in Toronto can be explained by traffic. So not surprising, this is what's been found elsewhere. Traffic is by far the most dominant and important source of noise in an urban environment. We did see from the monitoring that there was higher levels in sensitive areas. We were particularly concerned with these at schools, long-term care homes, and hospitals. So actually seeing higher than average levels in those locations, which of course should be the first ones targeted and looked at in terms of mitigation and reduction. As far as the exposure assessment go, we found 27% of residents were exposed to 24-hour levels above 65 decibels. And if you recall, we know that health effects start occurring around 50 decibels. 93% of the population were actually above WHO nighttime noise guideline recommendations of 45 decibels at night, and even 43 above 55 decibels, which again are in that certain health effect risk range. And then this hasn't really had much focus maybe in Europe. There's been a few studies and they found some evidence for it, but I think based on this and some other research published and coming out in the near future, there's definitely a stronger environmental justice component to noise exposure in the North American context. And I found in Toronto, this is quite drastic. So I used a public health approach where if more than 50% of the population in a particular area are exposed to a health risk, that it requires intervention. So I estimated which dissemination areas, which are small statistical areas with about 500 to 700 people in them across the city, which of those are at risk of having at least half of the residents exposed to excessive noise levels. And I found that based on income quintiles, the lowest income quintile DAs were actually 11 times more likely than the highest income quintiles to have this 50% exposure risk to them. So there's a lot of different ways to slice this, but this is definitely a pretty clear indication that this is a challenge in Toronto. This is just showing data at a map. With the map and for anyone who's done sort of mapping on environmental justice or exposures generally in Toronto, there's a pretty apparent and reoccurring U-shape through downtown and up the west and east ends of the city. And of course, as you'd expect, very, very likely to have these high exposures around busy highways and thoroughfares throughout the city. So the studies that came out then following this, using this data that took this more epidemiological approach, really fall in line with what's been looked at elsewhere, but are pretty unique in the North American and definitely the Canadian context. So we found, as has been shown elsewhere, a significant increased risk of diabetes. And you see, so there's a lot of information here, but just to note, these were adjusted for air pollution, comorbidities, and behavior. And we looked at both 24-hour and nighttime levels, and really didn't see much of a change when adjusting for those for diabetes. Hypertension or high blood pressure is one that there's sort of mixed evidence for, but we did see a weak but significant increased risk from that. The other study here looked at heart attacks and heart failure, so acute myocardial infarction and congestive heart failure, the medical terms for those. And again, we found results or risks that were consistent with studies done elsewhere, but again, relatively novel in a Canadian and North American context. These results show 8%. So a woman to think about this is an 8% increase in risk of a heart attack for every 10 or so decibel increase in noise levels. So starting at about 55 decibels, for every 10 decibel increase, there's an additional 8% risk of heart attacks in the general population, and similar risks for heart failure. Some changes based on adjustments, but again, these results held true when controlling for air pollution, socioeconomic status, and other risk factors that we know can potentially confound this relationship. The WHO did a very comprehensive meta-analysis a couple of years back in looking at all the different health outcomes that have been identified, and this is concerningly a pretty long list from hearing loss, adverse birth outcomes, annoyance through cognition, cardiovascular, metabolic disease, sleep, quality of life, well-being, and mental health. So there's studies that show effects on all of these health outcomes, but using sort of a very high bar and a high standard of evidence to, of course, not all studies are replicable. There can be confounding results in some of them. So they went through these and basically determined which ones have strong evidence and which ones need further evidence. And as our study showed, there's a very high and strong evidence for the fact of particularly traffic noise on the incidence of ischemic heart disease. So if that's the disease that potentially also leads to myocardial infarction or heart attack, that's one exposure relationship to health outcome that we have very strong evidence for. Beyond that, so hypertension, again, mixed evidence, so not strong according to their bar at least. So what next? Well, there's a lot of what next in Canada and Toronto more specifically, but more sort of more generally in the field. These improved exposure assessment methods and better access to health data are continuing to advance our knowledge and understanding. Really interestingly, and what will likely be addressed in Canadian context, but is happening elsewhere too, are identification of these pathophysiological mechanisms for differentiating the effects of stress versus what happens when your sleep is disturbed. And then what can we actually do about this? There's a lot of opportunities, and we don't by any means need to wait for more research. The evidence is strong enough as it is, I think, that justifies mitigation. Of course, this is complicated in an urban environment, particularly, but we do know traffic is the most significant source. So any type of traffic calming, traffic routing, traffic control measure are likely to have positive effects on noise as well. Building forms and standards continue to evolve. One of the most recent updates to national building standards in Canada actually did address noise transmission between walls. I didn't see that much of a change in considering environmental noise, but that's the opportunity, and it's advancing. Things like streetscape design and how we organize the physical objects in our cities does matter and can be done with noise mitigation in mind. Of course, regulation is an important one, and on this front, it's basically very weak in Canada. There's no federal rules or guidelines. There are provincial guidelines for mobile sources and some regulation for stationary sources, but the impact of stationary sources like air conditioners and factories tend to have less effect on health overall. So there's definitely some room for improvement there. And then what's mandated under legislation elsewhere, but we're still missing here, are action plans that cities can develop that include both measurement as well as performance metrics to see how we get to a point where, you know, the goal is then, of course, to decrease exposures overall, but pay particular attention in the beginning or at first to those vulnerable areas and sensitive sites of concern. So that's it. Hopefully I didn't go too much over time.
Thank you, Tor. That was so fascinating. I have a million questions. We are at the half hour, which we offer people the opportunity to leave, but we haven't gotten any questions in yet. So I'm thinking what we can do is, sorry, my video is not on. There we go. How about this, Roderick? You've been busy with some really juicy questions. So I think maybe I'll hand it over to you to ask one of your questions. And then I'm noticing in the chat that Dr. Murtaza Haidar from Ted Rogers School of Management has a number of questions there. And I'm hoping, Murtaza, you can stick around because we'd like to get to your questions. So maybe Roderick, you go for a question, and then I'll let you go to the Q&A and maybe ask one or two of Murtaza's. How's that sound? I'll go from there.
Sure, sounds good. Okay, so thank you for the talk, Dr. Oiamo. It was very fascinating. I have quite a lot of questions, but if I have to pick one of the questions to ask, it will be more of a practical question of, a lot of the monitoring equipments in the city, it often gets vandalized or stolen, and measurements have to be repeated to fill up the corrupted and the missing data. Do you see a way to better secure the equipment so that we can keep the integrity of the data and prevent the property damage?
Yeah, so actually, monitoring is not the state of the art for environmental noise assessment, because we don't really need to do it, because it's a very predictable physical property. Like I said, we can it's more of a data problem. If we know what sources there are and where they are, we can actually predict with very high precision what they are, and we don't need to go and measure those things to confirm them. We just it's like I said, it's very predictable. That being said, of course, monitoring is a good complement and supplement to help, and can and should be done in certain areas of concern. So I think I tried for some point to get a monitoring network set up in Toronto to have in certain places to have continuous monitoring going on, in part to see how things change over long periods of time, how to protect those, put them really high up, I guess. The monitors that I used for my campaign are relatively low cost. Actually, only one in the 220 locations that I used was vandalized, and that was across the street from a U of T frat house.
That's interesting.
I guess they thought we were targeting them specifically, but no, there was like more of the during the monitoring. There was actually more questions about the police. I did interact with the police a few times, that people had called, that they were concerned that there's sort of intrusion of privacy and why these things were being placed. But in all those cases, when we explained what was actually going on, there was no issue. But yeah, hope that answers the question.
Yeah, it seems like the police involvement is an ongoing problem. I've heard it from someone else who were deploying sensors saying the same thing. Neighbors complain to the police about potentially spying on them. But yeah, that's that.
Yeah, well, that's an important point though, because so that we don't record audio, right? We don't record sound. There's, I totally understandable that that's what someone would think if they see a sound level monitor nearby. But we can't. Some of them do record audio, but that's not of any need or use for our purposes.
Sounds good. Okay, I guess we will move into the audience Q&As. I think Murtaza has quite a few questions, and I'll start by asking where in the urban-suburban area is the noise exposure risk higher in terms of normalized by population and density? Yeah,
I mean, there's no easy way to answer that question. So trees, we were kind of chatting about this before the presentation started, but so as an example, I guess I've done modeling and exposure for traffic noise, at least in several cities now, and an interesting one that we found, a bit surprisingly, was that there's actually a higher proportional by population exposure to traffic noise in a city like London than there is in Toronto, and it's just by virtue of how many and how fast moving and the volumes on really busy thoroughfares are. So in Toronto, while we have a lot of roads, so speed is by far the most important determinant of traffic noise. You know, if we just enforce speed limits everywhere, that would probably be the biggest and first and most important step to do to reduce noise, and should be doable. So it's not really a straightforward question of sort of urban versus suburban. If you think about if you include sort of all sources and anyone who's been in a balcony in a high-rise building in downtown Toronto, you know, the noise levels actually go up as you get away from the street level, because you have a direct line of sight to so many more sources. And that includes HVAC systems on top of other buildings, or just, you know, a direct line of sight to the gardener or something like that. That will affect you higher up more than it will lower down. So it's quite tricky, and just I can't generalize based on that urban suburban divide. It really comes down to more. It's more specific than that, I guess.
There's a upvoted question from Lester asking, if noise is a problem, why hasn't the city gone to allow why has the city gone to allowing 24-hour work on infrastructure projects?
Yeah, so I'm well aware. So the noise bylaw allows for continuous work on what is considered critical infrastructure projects, and why they do that? I mean, the bylaw. I don't know. So the bylaws were initially the province designed a framework as a guideline and allowed municipalities to develop their own bylaws for noise back in the 70s. They actually hit the mark relatively well in terms of where health effects start and how and what levels should and could be enforced, even without a lot of the more recent research that has shown that. So the bylaws in general, the levels that they consider, sort of surprisingly in line with what we know from health. But I think the biggest problem with that particular issue and bylaws in general, they are reactive instruments. They're not proactive instruments. They don't, you know, most bylaws come into effect after, you know, a noise violation has occurred. You know, they're not by design there to reduce or improve, you know, health and noise over the longer term. So that's why we need noise action plans in combination with bylaws in cities to actually deal with things and reduce exposures over the longer term. With respect to, you know, that specific issue, you know, should we allow? So there's obviously a cost benefit there. You know, what's the cost to society of prolonging, replacing streetcar tracks, if that's going to take, you know, 4 weeks instead of 2 weeks by working at night. You could make that calculation by using statistical values of life and noise risk estimates, I suppose, but you know, that's a decision you would have to ask the city about.
Thank you. I think that kind of answers half of Stacy's question. Stacy asked, what would some of your recommendation be broadly or future thinking to reduce noise and overall well-being in the city? I guess you kind of touched on that. And then Stacy asked, what do you think citizens or community members can do to help advocate for change?
Yeah, so so partly what I just said, the bylaws are reactive instruments. They're, you know, they target you know, known, or at least what are perceived as you know, harmful sounds, I guess. So there's a bit of disconnect in some way because, of course, a concert on a weekend and in a neighborhood park is going to be probably extremely annoying to people that don't like the music or something, but there's not really evidence for, short-term things like that to have health effects. So most of the things that we respond to, so construction is even a tricky one because, it's of course incredibly intrusive and disturbing and annoying, but it's on a relatively short period of time, even if it's a few years, although we do see health changes over just a few nights of noise and sleep disturbance. Most of the effects are over sort of prolonged, if it's 5, 10, more so 15 years seems to be where those health effects come in. So we need, circling back to what we can do, we do need noise plans and action plans and metrics that target specific reduction in exposure rates by population, and whether those can also and should, of course, also include particularly vulnerable communities and targeting those at first. That's an opportunity there. So what can citizens, community members do to help advocate for change? Well, I guess individuals, that's not advocating, but just the first, like I said, the first thing we can all do, everyone just drove the speed limit. That would be like a good start. But of course, being involved with planning and community change and development, and making sure that changes that take place in your neighborhood where you have access to the table, include consideration of these things, and over time, becomes sort of integrated in the process. Just for pushing the decision makers to consider it, I think is one of the best things we can do.
Vicky, can you type in the chat and let me know if Dr. Oiamo's answered your question, because I think it's along the same line. And meanwhile, Kianush has a question regarding heavy vehicles. They're wondering if there is a research going on the effect of the heavy vehicles, more like commercial vehicles, contributing to the level of noise in day and night.
Yes, so we know a tractor trailer makes about 30 times as much noise as a car. So there's definitely an imbalance there, and so again, these noise models that I talked about, we do have to separate and specify the proportion of regular cars versus mid-sized vehicles versus heavy commercial vehicles. So they are included to the extent possible, and where data is available in noise modeling, and can of course be separated out if need be. So it'd be, I could even relatively easily, it would take some time, but go in and calculate exactly how much commercial vehicle traffic in Toronto contributes to the overall noise levels. There's not really in literature, at least yet, a focus on commercial versus other types of traffic in terms of health effects. It's just it's sort of all just considered, road traffic is road traffic. I think the end point of how are you going to do anything about it is an important consideration there. So just knowing exactly how much commercial vehicles contribute could be useful and important, but if there's no way to really deal with them specifically, then maybe it's not a good way to spend our resources.
So I'm just going to jump in here because we're at the 45-minute mark. We've got 15 more minutes left for deep dive. And I'm just going to invite others who are on the webinar, if you want to turn your microphones on, even your videos, we can have a continued discussion in real time. So I'll leave that up to you if you want to, and have some more back and forth, and maybe to follow up on some of the questions that we have already asked Dr. Oiamo. Any takers to begin us off? Murtaza, you've got like 10 questions. I don't know which ones to
I
ask.
think my supervisor has a question. I think Bilal wants to ask a question. Go ahead, Bilal.
Can you hear me? Oh yeah. Okay. So Murtaza can ask. Maybe I can wait. Once his questions are done, then I can have my small question.
I'm sure it's not small, Bilal.
So, so the basic question is that so you mentioned that 60% of the noise that is coming from traffic, and there's a big push towards electrification, and so we would see gradual market penetration increase in of electric vehicles on the ground. So how is it correlated to the decrease in noise, and what is the kind of level that we need to achieve to make our roads quieter? Is there any work done, or are you aware of any insights about it?
So I might ask you to just clarify the second part, but as far as electric vehicles go, I'm all for them, but the engine noise and exhaust pipe, of course, that's to be there's some go out and modify their pipes to make them louder, but your average exhaust pipe combined with the actual engine noise of combustion motors tend to dominate the signal, I guess, at lower speeds. So once you get up a little bit in speed, even like above 40-50 kilometers an hour, it's the tire noise is actually most of the contribution. So yes, there will be some reduction from electrical vehicles if we ever get to a point where it's 100% uptake, and it would make a big difference in places like downtown Toronto, where traffic speeds are generally lower, but once you get onto major thoroughfares or other roads, places where speeds are higher, then you're still going to be left with a pretty significant noise level. So maybe correct me if I didn't hear it right. So what are the levels we need to get down to as far as health effects? Was that what you were asking?
No, it was the other way around, in the sense that do we need 60% of our vehicles to be electric to have a significant decrease, or like what is there any sort of?
Yeah, so I don't know. We can try to study it if you want. I've been wanting to run some simulation models with because you can certainly include electric vehicles in these propagation models that I've been running. They have them built in and modeled, so it's not an impossible task by any means. But what the proportion would have to be, I mean, that's I don't think it would. We would never get to a point, even with 100% electric vehicles, if there's not a significant reduction actually in volumes, and all traffic is moved away from roads that people live on. There would still be people exposed to excessive levels.
Thank you.
Okay, there's a few hand raises. I think I'll let the people who haven't got a chance to get their question addressed to ask their question first. Christine asked a related question to what Bilal just asked, if there are any plans on the horizon to regulate cars that have been adjusted post-market to make much more noise than ordinary cars. I guess they're referring to those cars that makes change of engines, things like that, to make them sound cooler.
So, sorry, I was trying to look for the question, but well, sorry, can you just repeat it? Are there?
Sure. Christine is asking, are there any plans on the horizon to regulate cars that have been adjusted post-market to make much more noise than ordinary cars?
Right. So, well, it is illegal, right? Like there are regulations for exhaust pipe emission levels. Some of the really fancy sports cars seem to maybe skirt them a little bit, but there's there's just a lack of enforcement and control really as the problem. It's not so much the regulation. So there has been, maybe not so much with cars, but if you go to Port Dover on Friday the 13th, there will be cops outside the city sticking microphones into the exhaust pipes of motorbikes and giving them tickets. And that happens around cities as well. Edmonton actually is the only city that I know of in Canada, maybe in North America. I haven't heard of it anywhere else, but they've put in noise cameras. So they actually have, it was a pilot project that started in, I think it was 2018. I haven't followed up on it or seen where it's going now, but they basically have on busy streets, have cameras set up that are triggered by sound levels, and then we'll snap a picture of the vehicle causing that and then send them a ticket in the mail. So that's, the technology is there. How receptive the public is to that is a different story, I suppose.
Thank you. And Amjad asks why noise disturbance is usually only measured in decibels. The type and nature of the sound also plays a role, but they're usually neglected. Yeah,
so that's I could have spent more time on that at the beginning of the presentation. So we there's certainly yes, the characteristic of the noise matters. So that's in part why we separate sources in health studies. So that's why you see different dose responses. So the increased risk by a certain level of decibel increase isn't the same for air traffic noise as it is for traffic noise, as it is for railway noise, for health outcomes and annoyance. But they still use so if you're able to separate the actual source and the level from that, and if you average it over the 24-hour period or whatever it might be, it doesn't, once you've done that, it doesn't matter so much how it's characterized otherwise. So if you end up you can do things like number of peak noise events. So like how many times over a 8-hour period does the noise level go over a certain threshold or something like that. That ends up correlating very highly with any type of noise metric, as long as the source itself is isolated. And part of the reason then for using these decibel or equivalent sound pressure levels it provides an ability to compare and combine studies and do meta-analyses like the WHO has done, but in a part also because it became the sort of the dominant way to do it in the 60s, 70s with airport assessment particularly, and just kind of became ingrained. But yeah, so I think for soundscape research, there's more opportunity and perhaps more important to think about those characteristics of the sounds. But as from a health perspective, again, if you can isolate the source and model that in some way, then how you actually represent that number tends to matter less.
Roderick, I'm just going to jump in with a sort of bigger question, if that's okay. I'm curious, based on your research, Tor, with the city, what were the top regulatory or policy changes that the City of Toronto made as a result of your research, and which ones are still outstanding that you think would make the biggest improvement?
Yeah, so good question. I wasn't at all the tables, so I can't say sort of specifically which result ended up in under what part of the bylaw, but what I thought was, and there was other processes too. So the whole point of our assessment was really to look at health effects, and then obviously there was a community stakeholder involvement, best practice assessment from other communities. But I think overall, and again, I can't say if it was due to our study or other parts of it, the increase fines and control and attention towards construction activities, I think was probably the most significant improvement in that bylaw. There wasn't, a whole, quite a bit of attention was focused on, or like I said, people tend to care a lot about, single events that are disturbing, so like a concert in a park in a neighborhood, but there's not really, from a health point of view, it's not something we really can study for that matter. Well, we can, but it's not at the top of the list, I guess. So I think that much higher fines, the ability for the city to give out much higher fines, I think resonated within the construction industry. And then the most important thing that I thought came directly from our work on the citywide assessment was the medical officer, recognizing that and putting it into a report to council that there are, health effects of ambient noise exposures associated with traffic and things that well, traffic specifically, but transportation sources that the bylaw doesn't really address. And that was summarized as a recommendation to the province to start a process of regulating these noise levels. And then there was an election, and then other things have happened. So there's been a bit of a process to a certain extent got derailed a bit.
Okay, so we're almost at the top of the hour. I'm wondering, Roderick, over to you. Do you have one last burning question that's quick and
okay, it's my personal questions? Okay, sure. So Tor, I was wondering, so in some of your work, you mentioned that the government, I guess the policymakers, they really want to see, monitoring results or like propagation model results, because I guess in a sense, they're more physically realistic for them. But I was also wondering, for decision makers, it's usually easier for them it's better for them to have a more interpretable model, like say an econometric model, like a multinomial logic model, for them to identify what are the most significant contributors, and then for them to actually take actions to address them. Like, have you considered incorporating that into your future work?
So I guess make a clarify point earlier I made where I said, we don't need monitoring. That's for health studies. So on a big scale, like a city or even, a region or a province, there's Germany, for example, has done railroad noise assessment for the entire country. And I don't know if there was a single noise measurement done because, again, they just used data based on train noise and emissions. So on a big scale, that's where sort of the state of the art is. But of course, for regulation and smaller scale, monitoring is required and the state of the practice, and to a certain extent, state of the art, I guess. So, whenever whenever a project is proposed and it triggers this under the Environmental Assessment Act, then monitors go up to assess sort of baseline current levels, and then models are used afterwards to try to assess what the change from that project might be on those sensitive receptors. So that's part of your question, I think. And then the other part was, considering using other types of statistical models to separate the noise sources. So that we've done that. There, we've tried some, machine learning algorithms. There's multivariate models that try to, kind of parse it out. But not to be cheeky, there's so much noise in the data. It's really difficult to do, right? Because again, just a dog stopping by a monitor and barking at it for a few minutes might change the results. And if no one was there to sort of record that and take that out of the data, then it can mess it up. So it's tricky. My personal opinion, others will disagree. I think the better approach to get a good assessment of the noise, the soundscape of a city is to build it up from the ground with deterministic as much as we can. So, we start with traffic, we have railways, we have airports, airport noise. And then on top of that, yes, we can do some fancy modeling to kind of differentiate things. And, even in the work we did in Toronto, I found that, streetcar proximity, so probably just the screeching of the old metal wheels on the streetcars probably made a difference. But once you get to that sort of final level of variability beyond the transportation sources, it's very variable, right? So the return on investment for modeling that, I think, can be arguable, I guess.
Okay, great. Looks like it's top of the hour. We've got to wrap up. So I want to thank everybody, especially Dr. Tor Oiamo. This is super interesting. So many questions. Roderick, thank you so much for being my co-moderator today.
It was a pleasure.
Yeah, thank you so much. And seriously, we want to keep up with your research, which is fascinating in itself.
Thank you.
And also thanks to Claire and Luke who make these webinars happen. This webinar will be recorded and up on the City Building Ryerson website, probably in a couple days. And we have all of our other webinars in this series up there, and we'll include some links to Dr. Oiamo's research. So thank you everybody for being part of the series, and have a great day.
Thank you. And there's a few questions that we didn't get to. So for anyone, my email's at the beginning of the presentation. If you want to follow up with me on any other questions or topics, by all means, send me an email. I'm happy to discuss.
Thank you for your time.
Thank you.